Hello, everybody. I'm surprised that so many people stayed this late hour. And I choose this controversial title just to keep you awake. So my name is Tomi Vanek. I am Senior Technology Architect in Accenture the last 15 years. And I am one of the founders of this conference. And this is the second one. And so let's continue. So what are actually the web apps? Why did we invent web apps? Web apps were born with the promise to provide value instantly, so without any installations, what we made 20 years ago. You just go to a web page and instantly use the application. If it is just a one-shot application, you are go to a store and want to find something in the store. You don't want to install any application for that. Everywhere on each operating system. 20 years ago, it was a huge thing, and also nowadays, it's a problem on any device, on mobile phones, on tablets, on PCs, and for regular people. It means that it should be really nice, and it should be really usable, intuitive, the application. So let's just speak a little bit about the history of web applications, just to see why we have actually these frameworks. So in 90s, I don't know, who of you already programmed in 90s web applications? Perfect. So I'm not so old. In 90s, the web applications ran on server, mostly, because browsers were very buggy, incompatible. We were glad that something at least was rendered, but browsers were just dumb graphical terminals. Everything ran on server. There was a fight, if you remember, between Netscape and Microsoft. Microsoft saw very early that internet is a game changer. So they integrated very deep into operating system the web browser, Internet Explorer, and actually won this war of browsers. So in 2000s, there was no question which browser are you using, and actually all the developers developed just for Internet Explorer. Unfortunately, the applications, the enterprise applications, were for specific version of Internet Explorer. So the old versions of Internet Explorer were used longer than is healthy. And this way we had multiple versions of Internet Explorer, and that influenced also developers who were developing for internet. So not just for intranet, for an enterprise, but also for internet. And this just hold back the use of new features of browsers. Here in 2000s, in year 2000, came up a very modern browser. It was Internet Explorer 5 with XML HTTP request object. And that actually opened the way to build applications in JavaScript that could asynchronously communicate with the server. And that's actually the start of modern web applications that were running in browser. And that actually started also a dramatic change in architecture. In late 2000s, there started or the developer started to build really complex applications running in browser, and we moved from three-tier architecture, so something runs in browsers, something runs on application server, and on backend we had a database, to client-server application. So we had something on server, but the application actually and the whole state of the application run in browser. But in that days, the browsers or the JavaScript part of the browsers were not so mature, and that's why we used proprietary technologies for rich internet applications like Java applets, Microsoft Silverlight, and Flash. Macromedia Flash, later Adobe Flash. So Adobe bought Macromedia, but in beginning of 2010, epoch, there were a couple of things that dramatically changed actually the era and started actually the new era of web applications. First, you see the blue color is the Internet Explorer market share. It went to close to nothing. Green is Chrome, and black is Safari, Apple Safari. So you see that it changed a bit the market share and also the culture. So Internet Explorer was closed. Chrome, the core of the Chrome browser is open source. Also, Chrome developers developed together with the operating system also a discussion with other vendors about standards. So they came new standards, and something that we already forgot is the decision of Apple to not support proprietary rich internet application platforms. So Flash didn't work on Apple mobile phones, on Apple tablets, and that was actually dead for all of these proprietary platforms, and all the developers started to use JavaScript. JavaScript was also dramatically sped up, so the interpreter was much faster in modern browsers, and there came also the new frameworks. Frameworks tried to provide standard way to make complex applications from components. So here are just 3 of these frameworks, but there were much more. The next thing that was very important was the NPM module repository. So we could handle dependency management the standard way. And now we are in the era of maturing of web standards. So what brought us the frameworks and build tools? On the very beginning, we had really problems to build one code that would run on every browser seamlessly. And so that's why we took these libraries and frameworks that gave us this possibility to run the code. The next thing is that modularization was not standardized. Very late standardization. And even now, I will show you how to use already the ECMAScript 2016 modules. But really in your applications, also with legacy libraries. And the these two tools on the bottom, they are builders. So that's why, because we didn't have any modularization, standard modularization, we needed to use in old days builders. And why to go to use just standard web platform with HTML, cascading style sheet, and ECMAScript? Zero roll time, of course. My framework is inside browser. I don't need anything more. Native speed. Of course, the browser developers optimize this framework, this functionality inside of browser to be optimal, fast, and with optimal usage of memory. And there are no conflicts. So I can deploy my application together or componentize, create a component from my application, and I can use it on a web page that uses other framework like React or Angular. So now I switch. Do you hear me? Do you hear me? Yes. Okay, so I will go very, very fast through selected features in HTML and ECMAScript or JavaScript, just to show how it looks like to build modern applications with modern standards. So, okay. So the first one, HTML and JavaScript. So this is a very simple to-do application. Here is an analysis task. Some detail, and I will click on add new task. I will get a confirmation dialog, and if I say that okay, it's okay, so I get the analysis, and this has also a hidden detail, so I can open the detail. Everything that you see here is standard HTML. Let's put there another task. Here, this is a modal dialog. So if I click anywhere else, it's not working. So only the modal dialog. In old days, we made it with CSS, with JavaScript, with whatever. We made a lot of hacking. Now it's just a single HTML component dialog. You see it here, actually. Here is the dialog. And we can remove it. So let's look into the code, how it looks like. So this is the first example. HTML, nothing surprising. We have the title, some text, and now here we have an ordered list, and this is interesting. Here is a template, and that's actually a template that shows how should look a new element in this list. So we see here that I want to have a detail with a summary and with some description. Okay, so how will I use it? I will use this entry field set. So it's not a form, it's just a field set because the functionality is implemented in JavaScript. So I don't need to use HTML form. It's kind of hacky. I would like to use forms, but in this case, I want to show the strength of JavaScript. And here is the dialog. Dialog by default is hidden. And the template is also hidden. It's not shown. And for opening the dialog, we will use JavaScript. And here is the only thing for JavaScript. So you don't have here any include anything in the header, just plain import. The magic is here, type module. So we start to use standard ECMAScript 2016 modules. I import it from app.js, and this is the second magic. If you are using TypeScript, typically you don't add this suffix. If you are using JavaScript and you don't want to use any builder, any whatever what we used in previous century, so you have to put here the real name of the file that will be loaded by browser from the backend. And I will start this up. So it's in app.js. Let's open app.js. No surprises. I just search for the elements in HTML, and after that I will have here two actions that I want to bind to onClick, one handler, and on input, the second handler that will just disable or enable this button. Let's look into the get elements. Yeah. Also, no surprises. There is just a method that searches for all the HTML elements on the page. Here is an interesting thing. All the others are just not so interesting. It's just get element by ID. Nothing. That's something that we used to have in our JavaScript the last 15 years. But query selector came actually from, the idea came from jQuery, and it is a CSS selector that helps me to select any component in your complex HTML page. Of course, our page is not so complex, so let's look. This is the with ID task list, and give me the element template. Let's look into HTML. We have here the order list. Here is the ID task list and its child template. That's all. How will we... this is the easy way to just bind the handlers to elements. So here is the element that we found actually in previous code, and I put there a function that will actually be called by the event click or by event input. Let's look into the actions. So I will just ignore this update button disabling. That's quite simple. More interesting is on click, because on click we just opened the dialog. So let's see how we are doing this. It's confirm new task. Here is confirm new task. So on click we call this function, and it opens confirm dialog with add task handler. That's this function add task handler. And now, what do we do by config open confirm dialog? First, we fill in the text from the form. I add event listener for close of this dialog, and confirm dialog show modal. Very intuitive, and that's all. So this is modern HTML with JavaScript. Let's continue. Cascading style sheet. We have the second example. You see that the look and feel was made by a programmer. That's why we have professional designers, because programmers make very bad designs. But what we see here is that the CSS doesn't handle only look and feel, but also layout and optimization for different devices. So in this case, if I have a big enough screen, so I have the sections into columns. If I'm looking at it on maybe a tablet, so the sections are after each other. And if I'm going to mobile phone, so even the look and feel will change. How will we look at it in code? So I will switch now to the code. Am I going too fast? Is it okay? I can speak faster. So here you see the main with the sections. So that's what we saw from the structure perspective. And now we want to add there the look and feel and the optimization for different sizes for different devices. How do we do it? Here are actually the styles, and they are modularized. So it's not a big spaghetti code where nobody knows what to search where, but it's actually very well organized. Let's look into the index HTML. Here is the magic. I include only single cascading style sheet in HTML, but if I open it, so here is the structure actually. The order is important. So the later cascading style sheets override the more generic cascading style sheets that are before it. I will not go into all of the details. I will show just a couple of things. Here is the old way of optimizing for different devices. So I will say that for mobile phones, please change the background color to white. Remove the borders, for example. That's what you saw. That the look and feel was much simpler, so you can read it in mobile phones. Unfortunately, current developers just ignore all of us, old people with bad eyes. I want to show you one more thing, that is modern cascading style sheets have variables or constants, or however we will name it. The name of the constants has to have 2 dashes on the very beginning, so it's a little bit crazy way of writing the variables, but you see actually where are the variables. The second thing that is in modern cascading style sheets, but it's actually an old feature, 15-year-old feature, just we didn't use it so many times. So you can calculate actually variables, but the result is constant. So you see that each time, once I define the ratio, Here I have a layout system with geometric changes of the sizes. So for eyes, it is very nice. Okay, let's continue. The next one is modules. This is crucial. I will not show you the CSS. I will show you just what is, how can you use modules also with legacy code. So if you know Moment library that generates just human readable code for time, it is not optimized for modules. It doesn't have module support. So first thing, I make an alias with this import map imports that for Moment, please take this JavaScript. And the second thing is that, and this is a bit hacking, I defined post-install script that will run my small 150 lines JavaScript bundle dependencies. And it just rebundles the dependencies from node modules and puts the dependencies in ECMAScript format into web modules. So here is the Moment, and it's already the code is ugly, but it's already module. Let's continue. So that's modules. Communication. In communication, I will show you two things. One thing is asynchronous communication with promises, and the second thing is that I will not make requests only asynchronously, but also parallel. And the magic is here. So I will use async function. Async is just that in case that there is a keyword await, it will wait until the promise will fulfill. And in this case, all settled. There is an array of promises that will fulfill or reject. And here is fetchJSON method that I call, that is also asynchronous. And here I use standard fetch from the browser. So you don't need any library to make communication with server. Next thing, custom elements. I will show you and actually how the video element, the standard HTML video element, is implemented in Chrome. Here is a hack. You go to configuration and you allow show user agent shadow DOM. And now you see actually that the video element is not something monolithic implemented in C++, but it's actually standard components, standard HTML components. What is interesting is, here is the shadow DOM. The shadow DOM is a boundary. What is inside is hidden from outside. What is inside, it doesn't change something in outside. So in our case, I will show you an example of custom elements. This green title gets the color in HTML, and this red title is inside a component, a web component. Now I will show you these web components in code. So here is one web component, timer app, and inside of this component, I put some text, but in the text is second web component. Let's look just into the timer app. Here in timer app, how you write actually web components. It has to extend HTML element. Unfortunately, there is already a standard, mature standard, that is implemented in Chrome, where you can extend also other HTML elements, but it is not implemented in Safari. And in constructor, I use the template the same way as I used in first example, and I attach shadow DOM that you saw actually in the video element. I will have the very same shadow DOM also in my element. And I put there the HTML code that is actually here. Yeah. In clock element, it is more involved, more complicated. Here I have also attributes of the element. So I have two attributes. One is time. It is text. What is important by web components is that you have actually duality of attributes. So you have JavaScript parameters, and you have attributes in HTML element that you use. So I think the best way to handle this dualism is just to bind both, so both have the very same value. So I implement the getter and setter, and I read and write the attributes to the HTML. If you have a Boolean value, so that's more involved. I will not dive into details. And you have here standard callbacks. So by creating the element and by putting this element into DOM, the browser calls connected callback. And here you make all the initialization. In my case, I created a timer. And when the component is deleted from the DOM model, so disconnected callback is called, and I will just make all the cleanup. In my case, I just close the timer. And one more thing, I can define listeners on my attributes. So if somebody who uses my component changes my attributes, so I'm called, I will just define which attributes I should want to observe, and by change of the value is called this callback attribute changed callback. I will show the last thing, and that's my component communicates with the environment with events, the very same way as HTML components or other HTML elements communicate with each environment. So my component works the very same way. What is here special is that I don't use standard events from HTML, but I create my own custom event. I name it clock tick, and I define actually its value. Its value is here, current time. These two variables says that it should bubble up in the hierarchy of HTML elements or not. And the second one, if it should stay only in your component inside, or it should go out of the boundary of the shadow DOM. So I think that's all that I wanted to share with you. I will show you just last slide. This was my fallback if everything goes wrong. Unfortunately, if you use frameworks, they make all decisions for you. It's good for young developers, but it's very bad if you know what you are doing. Because typically there is not just a single use case, and typically your requirements are, for your requirements, the framework is not optimal. Typically, this is the way how the web applications look like. Here are just random 4 dimensions. I generated this with ChatGPT. I gave him, here you have these 4 dimensions, and provide me different web applications. And ChatGPT gave me this classification. Questions?
Thank you very much. Yeah, we have questions. Let's try to answer this one or two.
Is using plain JavaScript for a full stack web app for learning the fundamentals of JavaScript good idea? And then advance to framework for easier programming. I don't think that programming in frameworks is easier. It's a new era. We just are too used to go for framework, search for framework. For that is some library. But the library is 3 lines of code, and maybe there is a bug. And you have huge problems, or there is a security risk. And if we see the security risk during Weihnachten, so you have huge problems. I think 1.5 years ago or 2 years ago, we had the very same luck with Java library for logging, log4j. So all of you who had the nice bug fixing or changing in production very fast because of security risk, you know what I'm talking about. The second thing is that standards, these 3, HTML, CSS, and ECMAScript, are backward compatible. If you remember the changes between Angular 1 and 2, so you know exactly what I'm talking about. And that's why they are very slowly developed. So some of these standards, the development takes 5 years, 10 years, because they have to be very cautious also for all of the potential problems, potential situations, and also they address backward compatibility. So with frameworks, you don't have the assurance that it will be backward compatible. The second question. The first example looks like really retro. Yes, that was the intention. So if you have just a prototype, so you make it this way, and after that you can go to web components. Thank you very much. After the talk, I will be here, and we can discuss all the details, maybe also in code. Thank you.
Thank you.